In this video, we will take a look at template classes in C++. A template class is a class that you don't give a specific type to its data members, rather you give it a template type or a placeholder type to its data members. What I want to do today is I want to create a class called stack. And a stack is a data structure that stores elements in a stack order, or for example, elements on top of each other, basically forming a stack. The first element added to the stack is the last element to exit. And the last element added to the stack is the first element to exit the stack, because it is on top of the stack. Let's see how we could implement this stack object or class. To do this, what I'm going to do here is I'm going to say class stack, like this. So stack. And this will be our class that is called stack. Now I want this class to be a template class. So what I'm going to do right above the class, I'm going to say template, like this, and I'm going to give it a type. I'm going to say type name, and I'm going to give it a placeholder type or a template type. I'm just going to name it type, like this, okay? Now what I just did right now is I created a template class. I gave it a placeholder type or a template type for its data members. Well, let me go ahead here and create a data member. So I'll say private, and what will be this data member? So basically a stack is like an array that stores elements in a stack format. What I'm going to do is I'm going to include a header file called vector. This vector is a growable array. It can grow and shrink, meaning you can add elements and remove elements from it. What I'm going to do is I'm going to use this vector to represent our stack. And of course, if you want a full video about vectors, make sure to check out this video. But now what I'm going to do is I'm going to say vector, and now I'm going to specify what are the type or what is the type of data this vector will store. Well, basically, because I'm using a template class, I'll use my template type. So this vector holds a template type or a unspecified type. Now what I'm going to name this vector, I'm going to say stack, like this. Now, how do we use this template class? Let's go down to the main and see. When you are creating a template class object, what you're going to do is the following. You'll say stack and name the object. I'm going to say my stack. But this is not enough. You need to specify what is the real type or specific type of the data member. For example, I want this stack to store integers only. I will say like this, int. So what I did here is I gave a specific type to my template type. Right now, this stack can hold integers. But how about this one? If I say stack string like this, and I could say string stack. This stack right here holds a string. So this one right here holds integers, while this one can hold strings. So what is the main purpose of template classes? Well, basically a template class allows you to create a single implementation that can hold different types of data. Instead of creating different implementation for the same class that holds different types, you can use a template class that can simply hold any type for a single implementation. This is the real purpose of template classes. Now let's go ahead and build this stack class and see how it works. So I'll say public, and I'll create some functions. The first one function will be bool is empty. So this function will check if the stack will be empty. What I'm going to do is I'm going to say return this stack dot size equal to 0. The size function belongs to the vector. So the vector class here gives us this function that will find the size of the stack or the size of the vector. And if it is 0, well, but basically it is empty. Now I could go ahead and create another function which returns the size of the stack, and I'm going to say return this stack like this dot size, which will simply return the size of the stack. These are some basic functions. Now what I'm going to do is I'm going to create a function that simply pushes or adds an element to my stack. I'm going to call it push. So this function will add an element to my stack. Now the element will be of type, which is a template type. I won't give it a specific type because my vector here holds a template type. So that means the element that I'm going to give it will have a template type. Now what I'm going to do inside is that I want to add this element inside my stack. What I'm going to do here is I'm going to say this stack like this dot pushback, and this pushback function belongs to the vector class. It simply pushes or adds the element at the end of the vector. So what I'm going to do here is I'm going to say push back the element. So I'm adding this element inside my stack. Now, let's go ahead and create a function that will pop or take off the element inside the stack or remove the element from the stack. What I'm going to do is I'm going to say void pop like this, and you won't specify any argument or parameters. Well, basically in the context of stack or the stack data structure, when you say pop, you are basically taking off or removing the element on top of the stack. So basically the last element to enter the stack is the first element to be popped. So basically you are popping the element that is on top of the stack. So how to do this? Well, first of all, I will give a condition. I'm going to check if this stack is empty. So if it is empty, we cannot pop any element. What I'm going to do is I'm going to use this pointer, which represents the stack object. And what I'm going to do is I'm going to call the isEmpty function, which we created right here. It simply returns either the stack is empty or not. If it is, I'm going to say stack is empty, can't pop element, like this. So if the stack is empty, we cannot pop any element. Otherwise, we can. What I'm going to do here is in order to pop or take off an element from my stack, it needs to be the element that is on top of the stack. Here, with our vector implementation, which acts as our stack, basically the element that was added at the end is the element that should be popped first. So basically, when you add elements inside the vector, let's say I added 1, then 2, then 3. These are the elements that were added to my vector. But with a stack, it looks something like this. 3 is on top, 2 is in the middle, and 1 is at the end of the stack. So basically, when I want to pop an element from the stack, it should be the element that was recently added to the vector. So we're presenting the element on top of the stack. What I'm going to do is I'm going to say this stack like this, and I'm going to use the erase function, and what I'm going to erase is the last element added to the vector. I'm going to say this stack dot end, and the end function here is a pointer. It points to the last element inside the vector. So basically this is our vector. The end function will point at the last element inside the vector. So basically here you are saying erase the last element inside my vector. Okay, so this is the end function. So I'm basically right now erasing the last element that was added to my stack, basically the element on top of my stack. Now let me go ahead and create another function, which will be void display stack. It will simply display our stack. What I'm going to do is I'm going to loop in reverse inside my vector. Why? Because I want to display the element as if they are inside the stack. So I'm going to say for int I equal to like this stack dot size -1. I'll say I greater than -1 and I minus. So I'm basically looping in reverse inside my stack or inside my vector. So I'm starting at the last element and I will finish at the first element, which is at index 0. Now what I'm going to do here is I'm going to say cout like this. I'm going to say this stack like this, and I'm going to say dot at index I. So this one right here, the add functions, simply returns the element at this specific index. So I'm going to say end L right here. Now, how about we go ahead and test our stack? What I'm going to do down here is I'm going to say for a for loop, and I will simply generate random integers, and I will store them inside my stack. So I'll say my stack dot push to add the element inside my stack, and I'll say I plus 1. So my stack should look like something like this: 5, 4, 3, 2, 1. Let's go ahead and see it in my output. So I'm going to say my stack dot display stack, and let's go ahead and see how it looks. So this is my stack. The integer 5 is the element on top of the stack. So basically it is the top element of the stack. And number 1 here is at the bottom of the stack. So basically what happens if I say something like this: my stack dot and pop element. So basically I want to pop the element that is on top of the stack, which is the integer 5. Let me go ahead and print a before and after. So my stack dot display stack. Let's go ahead and see it. As you can see, this is the before starting from here, and this is the after. So basically we were successfully able to simply pop the element on top of the stack, which is the integer 5. So as you can see, this is how my stack looks like. And now if I say I want to pop again an element from the stack, 4 will be popped and we will be left with 1, 2, 3. So remember, with a stack data structure, the top element or the element that was added recently to the stack, which will be on top of the stack, will be the first one to be popped. So remember, last in, first out. And this is it about template classes in C++. I hope you enjoyed this video. Make sure to subscribe to stay up to date for the next C++ tutorial video. Alright, I hope to see you in the next one.